Hey guys, Mr. Apollos here. Today we are practicing an e-learning day, which means that whether you are at home or in class, you're essentially doing the same thing, and that is watching this Edpuzzle video, pausing it when you need, and making sure that you take notes as you go. Now, as you guys are familiar with so far, you know that in Edpuzzle videos, there's going to be built-in questions that you have to watch as we move through this. If you get to a question you don't know, make sure that you rewatch that section. All answers to questions should come just before they are asked, so that it should be pretty simple for you to find those answers and get those questions right. If at the end of this video you are not happy with the score that you're going to get on this, which means you've missed too many, make sure you contact your teacher to have them reset your question or reset your video so that you can watch it again and improve your score. Now, without further ado, let's go ahead and jump into today's notes. Now, just as a reminder, so far in the last couple weeks, we have spent a lot of time looking at this left side of the column and this right side of the column. Those are what we called the representative elements, which were the groups or families we talked about last week. However, we have skipped over this entire middle section and bottom section, so that's what we're going to be spending today looking at. Which leads us to our essential question, what's going on with the transition elements? Okay, now just as a reminder, if you're starting your notes, whether that be in your notebook, on a note page that was given to you by your teacher, or on your computer, make sure that this essential question is what you're putting along the top of the page, because what we're going to be doing is answering smaller questions that all lead us back to an answer about this one. Now, as we go through this, I am going to be hopefully trying to point out these key words to you as we go. These are words that you'll want to highlight or box or underline or do something to make stand out in your notes. As we go through this unit, we're going to be asking you questions about these terms and about the things that go with them. And if you have these highlighted in your notes, hopefully it will make it easier for you to find those answers instead of reading every single thing that you've written down. Now, our first little question that we're going to get into here, question A, is what are the transition elements? Okay, so that's that middle section we skipped. What are the transition elements? Simply put, they are groups 3 through 12. Now, if you have forgotten, remember that a group is a column on the periodic table. And when we went through our groups the other day, we skipped this whole middle section, which were columns 3 through 12. So we're going to be mentioning those now. Those are, by definition, the transition elements. There's a few things we want you to make sure that you know about these. First, that they are all metals. All metals. And secondly, they are typically found as ores when they are discovered as ores. And this is just a mixture of other things. Okay, so make sure that you know that. Again, ore is a key word, so I would recommend that you highlight that word. So these are metals that are found as mixtures of other things called ores. An example of this one would be like iron ore. When you dig up iron from the earth, it's not typically found as a pure chunk. It's found with a mixture of other things that are in the ground. So we have to go through a process of purifying that in order to turn it into the steel and other things that we need. Now, the reason why this is so important is because these are worth a lot of money. So if you ever inherit or buy property and you find a large amount of ores in the dirt of the property, you could potentially have those mined and make a good chunk of money on them. Now, there are some exceptions to this rule, and for example, two of those are gold and silver. Those can be found pure a lot of the time. This is actually seen in the gold rush that happened in the 1800s, where a bunch of people found gold or veins of gold in California, and it led to a big westward expansion because they all tried to go out there to find gold and get rich. So again, from this slide, we talked about the transition elements being in group 3 through 12. They're metals, typically found mixed with other things called ores. They're worth money, and gold and silver are exceptions to that. Now, here we have the transition elements just to show you those. And again, this is column 3 through 12 on the periodic table, which was this last one here. We've studied the left and right sides, but we kind of skipped over those for a couple different reasons. They're just not as predictable. Now, if you're looking at this video, the next logical question would naturally be, what's going on with these small ones down here? Which leads us to our next question. Question B, what about the ones under the table? What about the ones under the table? Now, the simple answer to these is that they are called the inner transition elements. So that is another one of your keywords. Make sure that you highlight that. Inner transition elements. They are the two rows. Remember, the periods are called rows on the periodic table. They are the two rows or periods that are found underneath the periodic table. Now, simply put, the top row is called the lanthanides. Top row. They exist from element cerium all the way to lutetium, which we'll look at in a second. And then we have the actinides, which is the bottom row or bottom period, which is thorium through lawrencium. We're going to spend the next couple slides looking at specific things about those, but remember, for each of them, you're going to want to know some simple characteristics as well as their locations on the periodic table. Here is an image showing you those locations of that lanthanide and actinide series. Again, the lanthanide series is in this top series from Ce all the way to Lu, which is lutetium. And the actinide series is this bottom one, thorium through lawrencium. Okay, make sure that, again, you know those locations of them on the periodic table. Now we're going to spend some time going through some interesting facts we want you to know about each one, which leads us to our third question. What's so special about the lanthanides? What's so special about the lanthanides? Now, the lanthanide is a key word that we want you to make sure that you highlight in your notes. And we're going to just list some common facts about them that you might be interested to know and put into your notes. Firstly, they are very, very soft. Okay, they're soft, almost like that alkali metal that you saw back in the last chapter, that piece of sodium that could be cut with a butter knife. They are also extremely similar to each other. They're very, very similar to each other. They're so similar, in fact, that it's really, really hard to get them to separate, and they occur often together. This actually led back in their beginning to be, back when they first discovered them, for scientists to believe that they were extremely rare. They were actually at one time called the rare earth metals. Now we know that's actually not true, and they're actually a lot more common than we originally thought. For example, cerium here is believed to make up almost half of the Earth's crust. So cerium makes up half the Earth's crust. Now, before we move on, again, the lanthanides are special because they are extremely soft. They are very similar to each other, so similar they were thought to be rare, but they realized that some of them are a lot more common, like cerium making up half the Earth's crust. So that's the lanthanide group. Again, that top row or top period in the intertransition elements. Now, our fourth question D here, is what's so special about the actinides? Actinides. We've talked about the lanthanides, but now we need to go back and talk about the actinide group. Again, actinides is a key word, so make sure that you highlight that or underline it in your notes so that you can find it quicker. Now, the actinide groups are special because they are all radioactive. Radioactive meaning that they break apart, they break down into smaller elements. Now, that doesn't sound like a big deal until you realize that this releases radiation. Now, some of you guys may remember that from last year, and that radiation is energy that can actually lead to cancer. Okay, now, luckily, most of these do not occur in large quantities on our Earth, so we don't have to worry about that, but we wanted to make sure that you understand that they do release radiation. Now, they're actually they are radioactive, which means they break down. There's actually only 3 of them that occur naturally on Earth. The rest are what we call synthetic, which means they're made in a lab. Okay, so 3 occur naturally. The rest are man-made. The 3 that occur naturally on our planet are thorium, which is Th, protactinium, which is Pa, and uranium, which is U. Now, even though these are radioactive, they still do serve a lot of purposes and have a lot of uses. One example of this is the element americium, abbreviated AM, and that one is actually used in our smoke detectors that are found in almost every home. Okay, if you have a rental property or even if you bought your house, your parents should have a smoke detector in their home. And inside that smoke detector, there's small amounts of americium that helps the detector figure out when there is too much smoke in the air that you breathe. Now, again, that is the actinides groups, or that bottom row or period of the intertransition elements. You need to know that they are radioactive. 3 occur naturally, but the rest are made in a lab. They are synthetic. And then you might want to make sure that you remember these 3 that occur naturally: thorium, protactinium, and uranium. Now, by this point, we have talked about all sections of the periodic table. So if I doodle out a quick image of the periodic table here, we started off by talking about our representative elements, which are on the left and right sides here. And then today we just looked at this middle part called the transition elements, and then the inner transition elements down here. So we've covered most of the information that you need to know about the periodic table, which leads us to the last and final question. We've kind of hinted at this as we went through. Are all these elements, question E, are all these elements found on Earth? Are they all found on Earth? The short answer is here. Mostly. Most of them are. Most of the first 92 elements are natural. Okay, now there are some exceptions to this. That's why I put this here. There are 2 exceptions in those first 92 that you might want to take note of. We will not ask you about these, but just something to take note of. The first one is number 43, which is technetium. And then the second one is number 61, which is promethium. Now they exist in such small quantities, and they're very, very hard to find. Now they are fairly easily made in the lab for whatever uses that we need for them. But for the vast majority, they are radioactive and break down very quickly. Now, hopefully you are thinking by this point, what about the others? Because remember, there's 118 total. 118 total that we know about. The first 92 exist naturally, but what about the rest of them? These are actually what we call the transuranium elements. And that is, again, a key word that we want to make sure that you highlight, transuranium. Basically, transuranium means anything bigger than uranium, which is number 92. So this is basically numbers 93 through 118. Now these are synthetic, which means they are man-made. They're actually made in a lab using what we call a particle accelerator. Now basically this is like a big gun that shoots atoms at each other. Okay, in this case, it'd be an equivalent to this would be like trying to shoot a cannonball at another cannonball and hitting them so accurately together and so perfectly that the 2 cannonballs fuse into one. That's similar to what they use this particle accelerator for. Actually, if you've ever seen Iron Man 2, he actually builds one of these in his living room to try and build that new element he puts in his chest. But it's like a little tiny gun. Now, the thing that I want you to know about the transuranium elements is that they are all radioactive. And we mentioned earlier how radioactivity means that this is where an element actually breaks apart or breaks down into smaller atoms. This does cause that release in energy we mentioned, typically associated with cancer or carcinogen effect. Okay, radon being a good example of this in the noble gases that we mentioned how that is found in rocks, and it breaks down and releases energy that can cause lung issues and lung cancer. So again, most of the first 92 elements are found naturally. All the rest, 93 and above, are called transuranium elements, and they are made in a lab using a particle accelerator. Here's an image showing you those elements. So we have 93 here. These are the transuranium elements. 93 finishes out the actinide group and then picks back up here in the periodic table through numbers 118. Okay, those are the transuranium elements, and these are synthetically made. Synthetic, which means that we make them in the lab. Okay, now there are 2 other elements we mentioned, which are right here, technetium and 61, promethium, that are also radioactive and not found naturally. We make them in the lab in large quantities, but because they're a little bit smaller, they're a little bit easier to make. All of these transuranium elements are mostly newly discovered, and they only exist for a few seconds at a time before they degrade. That leads us to the end of our chapter or the end of our essential question, what's going on with the transition elements. Hopefully you know that the transition elements include columns 3 through 12. they make up, and the inner transition elements in the bottom. And hopefully you can name some interesting facts about those as we go through. Now remember, this was an Edpuzzle video, which means you have been answering questions as the video progressed. If by this point you are unhappy with the video, then or your score that you're going to get on the video, make sure you contact your teacher to have your score reset. This means that you will have to watch the video again and answer the questions again, but it will improve your score. Do not forget that you can go back and watch this video at any time if you need to catch up on your notes or take more notes or just review the concepts. Hopefully you guys have a better understanding of the transition and inner transition elements. Contact your teacher if you have specific questions. Good luck and have a great day.